Yes, students, sorry for the inconvenience. I said no, so there was a bit problem with what network. We were facing some network issues, so that is why again we have started a new stream. Okay, so we are talking about the acidic nature of what phenol. What happens if suppose there is electron withdrawing group? What happens if suppose there is electron donating group? Right? So I am supposed to think phenoxide ion, whatever the phenoxide ion is going to form, whether that phenoxide ion is going to get stabilized by the presence of electron withdrawing group or by the presence of an electron donating. That I am supposed to think. Okay. So what happens if suppose there is a formation of phenoxide ion after donation of proton? This electron withdrawing group will withdraws electron. It will withdraws electron and decreases the electron density at what? OH bond. Decrease electron density at OH bond. Means the electron density is higher over here. Here the negative charge is intensified on what? Oxygen. So this electron withdrawing group will disperse the negative charge of what? Oxygen. Disperses the negative charge of the oxygen toward the molecule, and that stabilizes phenoxide ion. So that will give extra stability for phenoxide ion. So compared to phenoxide ion, electron withdrawing group substituted phenoxide ion is more stable. So that is why electron withdrawing group will make phenol. A presence of an electron withdrawing group makes phenols more acidic in nature. So electron withdrawing group substituted phenol are more acidic than normal phenols. So compared to phenol, when you are comparing phenol with an phenol with what electron withdrawing group, then that electron withdrawing group attached to phenol is more acidic. Please do remember this electron withdrawing group will disperse the negative charge on the oxygen. It disperses, it withdraws electron, it decreases the electron density on what benzene. So that is going to what? Stabilize the phenoxide ion. Hence, electron withdrawing group attached phenols are what? More acidic in nature. So that is the effect. Please remember, electron withdrawing group will increase the acidic nature of phenol. So that is the effect of substitute. Which effect? Electron withdrawing. So electron withdrawing group will increase the stability of phenoxide ion, and that is why the electron withdrawing group substituted phenol is more stable. So similarly, then let me talk about phenol which is having an electron donating group. And what? Electron donating group. So if suppose this phenol is attached to an electron donating group, right? So here I'm talking about this. If this electron donating group, what happens? Let's see. So this phenol is going to form what? A phenoxide. Right? It is going to form a phenoxide. There is an electron donating group, and it donates a proton. So now, whether this phenoxide ion is stable or not. If suppose it is stable, again it is also more simple. So now what happens? This electron donating group will donate electron and further increases electron density on O minus. Okay? So obviously that destabilizes the phenoxide ion. See, this electron donating group will intensify the negative charge on oxygen. It intensifies the negative charge on oxygen. Whereas this electron withdrawing group used to disperse the negative charge throughout the molecule. But here the electron donating group will intensify the negative charge at the oxygen itself. So that makes it highly unstable. So the presence of an electron donating group destabilizes what? Phenoxide ion. It destabilizes phenoxide ion and hence decreases or becomes difficult for particular phenol to donate a proton. So that is why I can say that this electron donating group will decrease. The acidic nature of phenols. So one thing I got to know that if you are comparing phenol with what? Substituted phenols. You compare the phenol, acidic nature of phenol or substituted phenols like electron withdrawing group and electron donating group. Phenol with electron withdrawing group is more acidic than what? Phenols. Then phenols are more acidic than the phenols with electron donating group. Right? So example for electron donating groups are, we can say methyl group, CS3, ethyl groups. So all alkyl groups you can say. Correct? Or NH2, amine group. amino group, or OCS3, the toxic group. So these are electron donating groups. So these electron donating groups will decrease the acidic nature of what? Phenol. Clear? Similarly, electron withdrawing groups like nitro group, you can say, are halogens, nitro group, NO2, halogens, chloro, bromo, iodo, fluoro. These all increases the acidic nature of what? Phenol. So that is why electron withdrawing groups substituted phenol are more acidic compared to what? Phenols, and electron donating groups substituted phenols are less acidic than phenols. Right? So let us take an example. Let us take an example of having an electron withdrawing group. Having an electron withdrawing group. Correct? So for example, I am having nitrophenol. I am having what? Nitrophenol. See, I am having OH and I am having a NO2 over here. Nitro, whether it is ortho, meta, or para, whatever. I'm having nitrophenol system member. I know nitro group is an electron withdrawing group. Right? So all nitrophenols, all whether it is orthonitrophenol, paranitrophenol, or metanitrophenol, whatever, all nitrophenols are obviously more acidic than what? Phenols. These are more acidic because this NO2 group withdraws electron and stabilizes phenoxide ion. Withdraws electron and disperses the negative charge on the oxygen and stabilizes this phenoxide ion so as to give a stable compound. Hence, nitrophenols, all nitrophenols are more acidic compared to what? Phenols. Okay, this is very simple. Now let me talk three isomers. One is orthonitrophenol, another one is metanitrophenol, and the third one is paranitrophenol. Right? So among ortho, meta, and para nitrophenols, I will say ortho and para nitrophenols are more acidic compared to meta. Are more acidic compared to meta. See, because resonance occurs, this phenol shows resonance. This NO2 also shows what? Resonance plus what? Inductive. So resonance effect predominates. Resonance effect plus R effect predominates. So, and I know resonance effect occurs at what? Ortho, R is what? Para. It operates at ortho. So meta will be unaffected by resonance. So that is why if nitro group is present at ortho or at para, then though there will be a stronger effect of what? Resonance. Positive resonance effect will be very strong over here at ortho and para. So that is why ortho and para nitrophenols are more acidic compared to meta, because effect will be more. So compared to phenol, I got to know that compared to phenol, which nitrophenol is more acidic? So the next one is what? Metanitrophenol. I will write metanitrophenol. So the metanitrophenol is more acidic. Then after meta, I am having ortho and para. Now among ortho and para, who is more acidic? First, let me talk about why ortho and para are more acidic compared to meta. I said you that there occurs a resonance. For example, in case of ortho, you see, in case of what? Ortho, there is N double bond O, single bond O. Right? There is N double bond O and what? Single bond O. So the resonance occurs over there. Resonance occurs over there. Right? You can see the resonance can be extended over here. Here it comes. So this electron will be transferred over here. Then this will be transferred over here. So resonance is extended in case of what? Ortho. For example, I am going to get OH double bond and O minus. So these are unaffected double bond. Similarly, if suppose there is a paranitrophenol, again this will come over here, this will come over here, and these electrons will come over here, and this will come here. Right? So again, this is also going to give a compound like this OH. plus positive charge on oxygen. So it will be unaffected. So there is a new bond present over here. There is a new double bond over here. O minus and O minus. So resonance occur. So if suppose NO2 group is present at ortho and para, resonance is extended. I will get two more resonating structures. More resonating structure. So more the number of resonating structure, greater will be its stability. But this is not possible. This is not possible if suppose present at NO2 group is present at what? Meta. It is not possible if it is present. See, you can see it will come over here. This will try to come over here. These electrons will come over here. So here in this carbon at meta position, resonance won't occur. So meta nitrophenol will not show you more number of resonating structure. Where do my ortho and para will extend their what resonance and they stabilize. So that is why ortho and para nitrophenols are more acidic compared to meta. Clear? To among ortho and para. So now we got to know why ortho para are more acidic than what meta. Okay. So now let me talk among what orthonitrophenol and paranitrophenol. So in case of orthonitrophenol, so there is a formation of intramolecular hydrogen bonding. So there is a chance of formation of what? Intramolecular hydrogen bonding. And double bond O, single bond O. So this is my orthonitrophenol. Correct? So this is my orthonitrophenol. In this case, so there is a chance of formation of what? Intramolecular hydrogen bonding. If suppose intramolecular hydrogen bonding taking place, if it takes place, then this hydrogen will become busy. So now it is not available for donation. So that is why ortho nitrophenol is less acidic compared to para. Ortho nitroacidic phenol is what? Less acidic compared to what? Para nitrophenol. Okay, so this is the order. Phenol is least acidic, and then comes my what? Meta, then ortho, then the more acidic is what? Para nitrophenol. But please don't think that the order will be same for all electron withdrawing groups. It is not same. It depends on which effect is acting, whether resonance or whether inductive or inductive resonance, both are then who is predominating, whether resonance is predominating or whether inductive is predominating. It depends on that. So this rule is not common for all electron withdrawing groups. This order is only for what? Nitrophenols. This order is only for what? Nitrophenols. Please do remember. Okay? So this is how it takes place, or the varies the acidic nature. So now take an example of electron donating group. I will talk about phenol. First, I will compare the acidic nature of a phenol with an phenol having an electron donating group, like cresol. You see, I am having cresols. So cresol, I am having CH group. This I know this is an electron donating group. It is an electron donating group. And I know electron donating groups intensifies the negative charge, or electron donating group increases electron density of OH1 and makes it difficult for OH1 to what? Cleave. A donation of proton becomes what? Difficult due to the presence of electron donating group. So that is why phenols are more acidic compared to the cresols, you can say. So compared to cresols, phenols are more acidic. Clear? One point is clear. So now I will write phenol over here. See, in this order, I'll write phenol over here. So now phenol is more acidic. Now phenol is more acidic compared to cresol. So let's see which cresol will come first, which will come next. So now let me talk among what? Ortho, meta, and para. Ortho, meta, and para. I'm talking about what? Cresols. Cresols. See, I said you effect will be more at ortho and para. Effect will be more at ortho and para. So in this case, now there is an inductive effect. CH3 will show you what? Inductive effect. So inductive effect predominates over what? Hyperconjugation effect. So cresols I'm talking about what? Cresols will show this cresol I'm having artocresol, I'm having what? Paracresol, I'm also having what? Metacresol. So these cresols will show you inductive effect, positive inductive effect, and also hyperconjugation effect. Positive inductive effect and what? Hyperconjugation effect. So hyperconjugation effect occurs only at what? Artho and para again, because of what resonance? Because meta is unaffected. So it occurs at what? Artho and para. That is why again effect will be more at artho and para. Now the effect is decreasing effect. Acidic nature is decreasing effect. So there is no effective hyperconjugation is not there at what? Meta. Okay, electron donating character is there. Electron donating groups will decrease what? The acidic nature. But if electron donating group is present at meta, then effect will be what? Less. Then compared to artho and para, meta is more acidic in nature. Correct? So metacresol is more acidic in nature. Very simple. Correct? So that is why after phenol I will write a metacresol. Metacresol is what? More acidic. More acidic in nature. So that is order. And the next among para and meta is over now. So don't stop thinking about what meta. So now compare among only what artho and what? Para. Among artho and para, what happens? You tell me. It's very simple. See, at artho and at para, among artho and para, who is more stronger? Where the effect will be more. So effect will be more at what? Ortho position. Because we know as distance increases, the effect goes on decrease. Effect goes on decrease. So effect will be more at ortho. It will be less at what? Para. You can say. Right? So that is why among this para and ortho, or else you can say ortho and para results are less acidic. Okay. However, as we know that positive inductive effect of substituent group decreases. This will show positive inductive effect. Positive inductive effect goes on decreases as distance increases. So effect will be more at ortho compared to para. So ortho will become least acidic compared to para. So that is why the next comes one is the next which comes is what? My paracresol. Paracresol is more acidic. So even compared to ortho. So orthocresols are least acidic. Orthocresols are what? Least acidic. Effect will be more. Which effect? Decreasing the acidic nature. Acidic nature decrease. This effect will be least more at what ortho. That is why orthocresol is least acidic than what? Para, then probably beta, and phenols are more acidic. So this is the order of what? Acidic nature for cresols, and this is for nitrophenols. So this order is not same for all electron donating groups. This is not same for all electron donating groups. Okay. Then also we can compare. We can also compare of what? NH2. NH2 is also what? An electron donating group. NH2. Aminophenols we can say. Aminophenols. Imagine I'm having what? Aminophenols. Phenol, OH. I'm having what? Aminophenol. Or else you can say what? Methoxyphenol. You can say what? Methoxyphenol. Aminophenol or methoxyphenol. Right? So in this case, this both NH2 group and OCH3 group will show you resonance effect. At the same time, they also show negative inductive effect too. They also show what? Negative. See, they show resonance effect too because these two, nitrogen and oxygen, have lone pair of electrons. So they involve in resonance. So one thing I got to know that NH2 and OCH3 will show resonance. At the same time, this is a nitrogen electronegative. This is the oxygen electronegative. This also will have negative inductive effect too. They also will have negative. So they will show positive resonance and negative inductive. Correct? No? Positive resonance and negative inductive. Correct? No? So at ortho and para position, resonance involves that I know. Resonance occurs. So that predominates. And these are electron donating groups, and ortho and para substituted phenols. whether it may be amino or what methoxy, both are least acidic. Least acidic. If suppose this NH2 or methoxy, if suppose this NH2 or methoxy group is present at meta position, then this will not involve in resonance. That I know. Then NH2 here in this case, NH2 will only show you what negative inductive effect. Then I know that negative inductive effect is nothing but electron withdrawing capacity, right? Nitrogen. It will try to withdraw the electron and acts as electron withdrawing group now. So because here the resonance won't occurs. So there is no positive resonance effect here. NH2 in this case, in case of meta-substituted compound, it is showing what? Negative inductive effect. Means it withdraws electron from what? Oxygen. It withdraws electron from what? Oxygen, being more negative, because there operates only what? Negative inductive effect. Positive resonance won't operate. So effect of donating group acting as electron donating group what? Reduces or becomes less. So there is this negative. So one thing I got to know, even OCS32, even what OCS32, correct? But electron withdrawing capacity of OCS3 will be greater compared to NH2 because nitrogen is less electronegative compared to oxygen. So one thing I got to know that whether it is NH2 or OCH3, whether it is NH2 or OCH3, meta-substituted phenols. Meta-substituted phenols or aminophenol is more acidic. That is more acidic compared to ortho and para-substituted aminophenol. Then compare the meta-substituted methoxyphenol. Meta-substituted methoxyphenol. So here in this case also, resonance effect won't occur. Resonance effect won't occur. Resonance effect won't occur. So this is also I can say meta-methoxyphenol is more acidic among ortho and para-substituted methoxyphenols. Then among meta-methoxyphenol and meta-aminophenols, the withdrawing capacity of oxygen is more because it's a more electronegative. That is why I can say that meta-methoxyphenol is more acidic compared to meta-aminophenol. Meta-methoxyphenol is more acidic compared to what? Meta-aminophenol. So these two are obviously even more acidic compared to what? Phenols. Correct? So this is what the acidic nature of what? Phenols. Okay, so I'm talking about NH2 and OCS3. These are electron donating group, but at the same time they will show negative inductive effect too, because they are having an electron withdrawing group. Because they will show positive resonance because they have lone pair of electrons. So positive resonance effect operates only at ortho and para. So ortho and para, the effect will be more, and they will decrease the acidic nature. But at meta position, positive resonance effect won't occur. There occurs only negative inductive effect. Hence, meta-substituted compounds of these phenol are more acidic. That's why I wrote among ortho and para. Among these two, OCS3 is a strong withdrawing. That is why methoxyphenols, meta-methoxyphenol is what? Even more stronger acid compared to what? Meta-aminophenol. So one more thing, the last one, last point you remember, I even need to talk about what? Halophenols too. I'm supposed to talk about what? Halophenols. All halophenols. Because halophenols are nothing but my electron withdrawing groups. Electron withdrawing groups. These halophenols are obviously more acidic than what? Phenols. Obviously what? More acidic than phenols. Right? That you remember. So all halophenols are more acidic than phenols because halophenols are electrons withdrawing groups. Then among those ortho and para, ortho-halophenol is more acidic than meta-halophenols. Right? Meta-halophenol is even more acidic than para-halophenols. Correct? No? So ortho-substituted halophenols are more acidic compared to what? Para-substituted. I know as distance increases, negative inductive effect, because they will show negative inductive effect. They will show resonance effect too, but negative inductive effect dominates. Negative inductive effect, as distance increases from the reactive center, the effect goes on decrease. So that is why electron withdrawing capacity stabilizes and will increase electron density. Increase acidic nature. That is why all ortho-substituted halophenols are more acidic than meta-substituted than para-substituted. Then among fluorine, chlorine, bromine, iodine, who is more reactive? So obviously fluorine. So fluorohalophenols are more acidic than chlorohalophenols. Chlorohalophenols are more acidic than bromohalophenols. Bromohalophenols are more acidic than iodine. But there is an exceptional case in case of what? Fluorohalophenol. There is an exceptional case in what? Fluorohalophenol. Orthofluoro. So I am expecting orthofluorohalophenol to be what? More acidic, but it's not so because there is a formation of what? Intramolecular hydrogen bond. So due to the formation of this one, orthofluorophenol is not much more acidic in nature compared to orthochlorophenol. Orthochlorophenol is more acidic compared to. Generally, orthohalophenols are substituted are more acidic except this case. This is less acidic because of due to the formation of intramolecular hydrogen bonding. Okay, so this is how this acidic nature varies among what phenols. We would have given many more examples, but we are up short and we are very short period of time. We are supposed to cover so many chemical properties still, and we'll discuss rest of the things in next class. Thank you.